on the recording. Students, timings you should be strictly following in the upcoming days, because we don't have that much of time, so all have to join on time to the class. If any of your friends are there to join, please call them immediately and tell them to join fast. Waiting for others is actually a waste of time for the people who are joined, so make sure that you are joining on the correct time. We want to start the class exactly at 12 o'clock, so be conscious about the timings and everything. Okay. Yes, I think we can start the class, right? Are you feeling like any more students will be joining? Shall we start the class or shall we wait for a few more minutes? What you are saying? Can we start the class or should we wait for a few more minutes? Okay. Okay, we'll wait for one more minute. After that we can start the class. Okay. Sorry for those who come on time. Okay. In this time you can just go for the revision of the last class that we have discussed. Okay, I think this is enough. The time is enough. We'll be starting the class. So, good morning. Welcome all of you for your chemistry class. Good morning, everyone. Sorry, it's not good morning. I know it's good afternoon. Yes, today we'll be starting or we'll be continuing the chapter chemical bonding. Yesterday we have started the chapter and we have just gone through few concepts, and today we will be discussing or we'll be continuing the remaining important concept of that chapter. So, hope all of you are ready and set for this chapter, and if you are ready for this chapter, please give me some reactions in the chat box so that we can start it with a green signal from your side. Yes, so hope all of you are ready and doing well and doing great. And now we'll be starting the chemical bonding chapter today here. So students, in the last class, let me go for a quick recap. Of the last class that we have discussed. Yesterday in the last class we have discussed the chemical bonding. In that we have discussed few topics like ionic bond, lattice enthalpy, hydration enthalpy. I want everyone to recall these three topics that we discussed in the last class. Okay, ionic bond. What is ionic bond? Ionic bond is also called as electrovalent bond, or it is also called as non-directional bond. Ionic bond is formed by the complete transfer of electron. An ionic bond will be forming between a good metal and a good non-metal. A ionic bond can form only if the metal is having low ionization enthalpy and non-metal is having high electron gain enthalpy. These are the points that we have discussed about ionic bond. Okay, after that we have discussed about lattice enthalpy. Okay, what was lattice enthalpy? Lattice enthalpy is the enthalpy or the energy released when 1 mole of ionic compound is formed from its constituent element. And what was the equation we discussed for lattice enthalpy? Anyone is remembering the equation that we discussed for lattice enthalpy? Lattice enthalpy is directly proportional to what and inversely proportional to what? Anyone? Just wait a minute. Yeah, lattice enthalpy is directly proportional to, yes. Okay, yeah, very good. Lattice enthalpy is directly proportional to charge and inversely proportional to size. That is what we discussed for lattice enthalpy, directly proportional to charge and inversely proportional to size. And one more concept we discussed in the last class. What was it? That was hydration enthalpy. It is the energy released when water is added or water is hydrated to a ionic bond. And hydration enthalpy also we have discussed. It is directly proportional to charge and inversely proportional to the size. Okay, and both of these we have discussed. It is having a relation with the solubility. How it is related with the solubility? Anybody have an idea how it is related with the solubility? Lattice enthalpy is inversely proportional to the solubility, and hydration energy is directly proportional to the solubility. And for a compound to be soluble, for solubility of a compound, the lattice enthalpy should be lesser than, or hydration enthalpy should be greater than lattice enthalpy. These are the points we discussed in the last class. Is it clear to everyone? Was the concept we learned in the last class, was it clear to everyone at that time itself? Yes. Okay, and I think we haven't completed the hydration energy. Part. We discussed that hydration energy is directly proportional to the size of hydrated ion. That is, more the hydration energy means more water molecule will be surrounding that ion, which means size of hydrated ion will be higher. That is, hydration energy is directly proportional to size of hydrated ion. Okay, and if I am asking you what is the mobility, how mobility of the hydrated ion is related to hydration energy, can anyone let me know how the mobility is related? Anybody have any idea about this? Higher the size or lower size will have higher mobility? Higher size or lower size? Which one is having highest mobility? Who can run faster, cheetah or elephant? Cheetah only, right? What is the reason? Size is small. So one which is having lesser size, that will be having highest mobility. That is the case. So I can say size of hydrated ion, it is inversely proportional to the mobility, inversely proportional to the mobility of ion, Now if I ask you what about the conductivity? Conductivity you can tell. Based on the mobility you can say conductivity. Conductivity is directly or inversely proportional to hydration energy. Can anyone? Yes, very good. Hydration energy is inversely proportional to mobility, because higher the mobility, higher will be the conductivity, because conductivity is all about how easily an electron can move or pass. Okay, so it directly inversely proportional to the conductivity. So this is the point that you have to note down in the case of hydration energy. Yes, is it clear? If it is clear, I can give you a question. 2 questions I will be giving. I think I have given this question yesterday itself. You have to find out the order of size. First one is lithium aqueous, sodium aqueous, potassium aqueous, and the second one is lithium. All these are ions. Lithium in gaseous state, then sodium in gaseous state, and potassium in gaseous state. What is the order of? In the case of first one, aqueous, what is the order? Which is having highest size? Give me the answer. Yes, lithium is having highest size, that we have discussed in the last class, and the order is Li plus aqueous greater than Na plus aqueous and K plus aqueous, because the aqueous is mentioning it is about the size of hydrated ion. Now what about option B? Not option, what about the question B? What about the question B? Li plus gaseous state, Ni plus gaseous state, K plus gaseous state. Which is having highest size? Yes, in this case potassium is the highest case. So in this case, as it is not the hydrated ion, potassium is highest size, then sodium, then lithium. So this will be the confusion, or it will be the mistake that you will be doing in the question. You won't be checking whether it is gaseous or aqueous. You have to find out the order only after checking gaseous and aqueous. Is it clear to everyone? Is it clear to everyone? If it is clear, give me thumbs up. Yes. Now if I ask you, what is the order of conductivity? Order of conductivity of A. Order of conductivity of A, question A, or the order, the options, question given in the A. What is the order of conductivity? K is more conductive, sure. Which one will be more conductive? We already discussed. The one which is having lesser size will be more conductive. Yes, very good. So I can say that conductivity order, K will be having highest conductivity, K aqueous, highest conductivity, then Na plus aqueous, then Li plus aqueous. This is the order. Okay, so these are the few questions that is coming from this part. Hope it was clear to everyone. Now we will be moving to the next part of it. Yeah. Okay, there is a small question for you. I want everyone to solve this question and get me the answer. Easiest question. Among the following, which compound will show the highest lattice enthalpy? Lattice enthalpy, how we can predict the lattice enthalpy, that already we discussed. Tell me, which is having highest lattice enthalpy? Lattice enthalpy is directly proportional to charge, inversely proportional to size. Now if you look these options, what you can see? All are, here the anion is same, here the anion is same. Now how we can compare the lattice energy? We can compare the lattice energy by checking the charge by size of cation only. And in the case of cation, all are having, yes, what's the answer? Yeah, someone else?
Option B.
Option B, yes, very good. Option B is the correct one. Now if I am checking the cation, potassium, cesium, sodium, everything is having positive charge. Now I can't compare it by using positive charge. Then how, what is the next thing I can compare? I can compare it with the size. Which is having lowest size, that is having highest lattice enthalpy. Among these we can say sodium. Sodium ion is having lowest size and so highest lattice enthalpy. Okay, this is how we have to solve this type of questions. So NIF is the correct one. Shall we move to the next question? Yes. Okay. Now the next important concept in this chapter is Fajan's rule. Fajan's rule is a very important one. What is Fajan's rule? We all know that everything is not perfect. That is, for if I am talking about ionic compound, all ionic compounds are not 100% ionic. There are some kind of covalent character is also there in an ionic compound. And Fajan's rule is telling all about the covalent character in an ionic bond. How we can identify the covalent character in an ionic bond, and how we can arrange the ionic compound in the order of their covalent character, that we can discuss in the Fajan's rule. Okay. What is Fajan's rule? Look at this picture. In the case of ionic bond, there will be a cation and there will be an anion. And this cation is having a pulling power, right? Cation will be having a pulling power, and anion will be vulnerable to the pulling power of cation. That is, what you can see is when cation and anion comes closer, the shape of anion, we know that what is the shape of an anion? It is having a spherical shape. We are assuming that anion is having a spherical shape, and in the presence of cation, the spherical shape of anion will be distorted to distorted spherical because of the pulling power of cation. Cation will be pulling the electrons of anion towards itself, and as a result of that pulling, you can see the electron or the charge density is coming coming closer to the cation in an overlapping way. In an overlapping way. What is this nature? Here you can see charge density. Charge density is coming and is overlapping. And this overlapping is not related to ionic bond. Ionic bond means it is complete transfer of electron. This overlapping is something that is related to covalent bonding, right? That is exactly what we are talking in the Fajan's rule. That is, every ionic bond have some kind of covalent nature. This is what covalent nature. Okay, for that only we are using the Fajan's rule. Now it's all about how we can identify the covalent character. That is what the question. Now here we are introducing two terms. Which are the two terms? For cation, this pulling power of cation, I am going to represent it by using polarizing power of cation. Polarizing power of cation. And the ability of anion to change its shape from spherical to distorted spherical. Distorted spherical is, we will be calling it as polarizability of anion. Polarizability of anion. Okay, polarizing power of cation and polarizability of anion. And how we can find out the covalent character is, covalent character is directly proportional to polarizing power of cation and also is directly proportional to polarizability of anion. This is the point that you had noted down. Covalent character of an ionic compound is directly proportional to polarizing power of cation. What is this power? Ability of a cation to change the shape of an anion from spherical to distorted spherical. And polarizability of anion, ability of an anion to change it. Yeah. Anybody want me to discuss it once again, or is there any problem with audio, video, anything? What happened? Dhanishri, is it fine? Everything is clear? Audio, video? Okay, thank you for the response. Okay. So covalent character is directly proportional to polarizing power of cation and is directly proportional to polarizability of anion. Now how we can find out the polarizing power of cation and polarizing power of anion? That is by charge by size ratio. Polarizing power of cation is directly proportional to charge and inversely proportional to size. And polarizability of anion is directly proportional to charge and directly proportional to size. This is the box. I want everyone to take a note of it. This is the simplified version of Fajan's rule. Only thing you need to go through this only for understanding Fajan's rule. Question will be asking what is the order of covalent character in an ionic compound. How you will be finding the covalent character? If you are comparing with the cation, you have to go for the polarizing power of cation. It is directly proportional to charge and inversely proportional to size. If you are going for the if you are comparing the anion, you have to compare the polarizability of anion, which is directly proportional to charge and size. That is what Fajan's rule is. If it is clear, I can give you some questions and you can make it little more clear. Are you clear with this? Shall we move? Students, give me the response from your side. Yes. So that, yes, thank you. Now one more thing is there, that is what pseudo noble gas configuration. I have written it over here. These are the two factors. One is polarizing power of cation and the other one is polarizability of anion. Now one more thing is that is pseudo noble gas configuration. That is, if you got an ionic compound which is having a pseudo noble gas configuration. Example, I can say CuCl. CuCl is having a pseudo noble gas configuration of copper. Copper is having pseudo noble gas configuration, that is 2,8,18. Whenever you got any ionic compound or whenever you got the comparison of covalent character, if any of the ion is having pseudo noble gas configuration, that will be the most covalent character among that all. Pseudo noble gas character will dominate among all. Pseudo noble gas configuration dominates among all. That is, out of the three, polarizing power of cation, polarizability of anion, pseudo noble gas configuration is there, that compound will be having the highest covalent character among all. Got it? Got it, everyone? Okay. Yes. Yeah, pseudo noble gas configuration means they are not noble gas, but they have a configuration of noble gas. If you observe copper plus, if you observe the outer electronic configuration 2, 8, 18, this is similar to a noble gas configuration, right? This is similar to a noble gas configuration. So this type of configuration we are calling it as pseudo noble gas configuration or pseudo inert gas configuration. If they have NS2, NP6 and ND10, they are having noble gas configuration. Got it? Yes, thank you. Okay, remaining the point I have said that I have mentioned here in the table, you can check it in the slide. Okay, shall I move? If you are clear with this concept, I can move to the next page. Okay. Yes. Next page is about the consequences of Fajan's rule. How through the Fajan's rule we will be able to get the order of covalent character. From the order of covalent character, what are the other things that you can find out? That is, I will be discussing in this slide. That is melting point, solubility and color intensity. Covalent character is inversely proportional to melting point and solubility and directly proportional to the color intensity. This is another point you can note down. That is, if you find out the order of covalent character, you can also find out the order of solubility, melting point and color intensity. Yes. Have you noted down, students? Yes. Okay, just note it down. After that we can move. Okay, if it is done, you can put a thumbs up in the chat box. Okay, I hope everyone have done. Yes, thank you for your response. Yes, give me the answer for this question. First one, arrange the following in increasing order of covalent character. Very easy question. You should not lose any mark from this type of easy questions. Tell me the answer. Covalent character, how you have to find out? By using Fajan's rule. In Fajan's rule, how you will be finding? Polarizing power of cation, polarizability of anion and pseudo noble gas configuration. Among these, if any compound is showing pseudo noble gas configuration, then that will be the highest covalent character. Among all these, you can't find anyone with a pseudo noble gas configuration. So we are ignoring pseudo noble gas configuration here. Now how we will be finding out the covalent character order? Here, cation if I am observing, all are same. Cation are same. If the cation is same, then how we can find the order of covalent character? We have anion, we have our anions. How we will be finding the covalent character if you have different anion? Covalent character is directly proportional to the polarizability of anion and is directly proportional to the charge and size. Here I can find out the covalent character order only through charge and size. Okay. Now, if I look at the charge, fluorine, chlorine, bromine, iodine, all are having same charge, that is -1 only. Then how I will be finding? Size is there. One which is having highest size will be having highest covalent character. So I will be writing the covalent character order. Which is having highest size among halogen? Iodine is having. So Na will be having, sodium iodide will be having highest covalent character, then NaBr, then NaCl, then NaF. This is the correct order. Have you got this one? Are you also got the same or any different one? Yes, hope all of you got the same order only. Now go to the question number 2. Which of the following has the lowest melting point? Lowest melting point. Which is having lowest melting point? Give me the answer in the chat box. CaCl2, MgCl2, BeCl2, SrCl2. Lowest melting point means it will be having highest covalent character. How we can find out highest covalent character? Here all you can see in the case anions are same. Anions are same. So I can't compare the covalent character from anions. Then what is different? Cation is there. Cation is there which is different. And this cation is having, what is the order of the charge and size of cation? All belongs to the alkali earth metal which is having +2 oxidation state. Then we can find out the covalent character only based on the size. What is the size order? First which one will be coming? Beryllium, magnesium, calcium and strontium. This is the order of size. Among these, which is having highest size? Which is having highest size? Strontium is having highest size. Highest size will be having highest covalent character or lowest covalent character? Highest size have highest covalent character or lowest covalent character? Here I will be checking the polarizing power of cation. Polarizing power of cation. It is directly proportional to charge and inversely proportional to the size. So one which is having highest size will be having lowest polarizing power of cation and is having lowest covalent character. Okay, so what is going to be our answer? What is our answer? Sr is having lowest covalent character and highest melting point. And beryllium is having what? Beryllium is having lowest size, right? Lowest size, highest polarizing power of cation and highest covalent character. It is having highest covalent character and lowest melting point. This is how you can find out. And so what is our answer? Option C is the answer. Okay, have you got this one? Are you clear with this question? Yes, yes, I need the response from everyone. Yes, okay. Few students have given the answer in the chat box. Yes, very good, Surabhi, Kiran, Surabhi, yes, good. Okay, if you are done with this, can we move to the next part? Okay, I am moving to the next part. Next is about valence bond theory. Valence bond theory and the bond strength. What is according to valence bond theory? According to valence bond theory, atoms with a half-filled orbital, they will be coming and overlapping and will be forming bond. That is according to valence bond theory. And according to valence bond theory, the two type of bond that we are discussing is sigma bond and pi bond. Sigma bond and pi bond. And the question is all about strength of sigma bond. Strength of sigma bond. If I am talking about sigma bond, there are two type of bonds are there. Sigma bond, pi bond. Sigma bond is formed by the head-on overlapping. Head-on overlapping, that is overlapping along their internuclear axis. Okay. If I am talking about sigma bond, what is the order of strength of sigma bond? Three type of sigma bonds are there. SS, SP and PP. What is the order of strength of sigma bond? What is the order of strength of sigma bond? Which is having more which is more stronger? Which is more stronger? Yes, very good, Chris and Surabhi. It is PP. Why PP is more stronger? Why PP is more stronger? Because of the directional character. P orbital, if you observe, the electron density is oriented in a particular direction. Electron density is oriented in a particular direction. Because of that, there is a high probability that electron can be present in this shared part. So that is why the PP bond is stronger than sp than ss. If I observe, or if you observe the s orbital, it is spherical in shape and electron density is equally distributed everywhere. Because of that, the probability of finding electron in the shared part, it is very less. That is why ss bond is weaker and sp bond is stronger than pp bond is stronger. Got it? Now for the same energy orbital, for the same energy shell, if you observe, what will be the order? If I am asking you 1s and 2s, they are same sigma bond. Which is having highest strength, 1s or 2s? Give me the answer. 1s or 2s? 2s is stronger. Are you sure? Which one will be stronger? The one which is very closer will be the strongest. We all know that. One more thing we have discussed in the beginning, strength is also inversely proportional to internuclear distance. Strength is also inversely proportional to internuclear distance. Yes or no? Yes. Okay. Among these, which is having lesser internuclear distance, 1s or 2s? 1s or 2s? 1s is having lesser internuclear distance because these two are one or principal quantum number 1, which means they are very closer. Size is less. As size is less, they will be more closer. If they are more closer, the strength will be stronger and bond length will be lesser. Okay, so this is the order. Is it clear to everyone? Strength of sigma bond? Yes. Okay. Now if I am talking about pi bond, what is the order of pi bond? What are the order of pi bond? What are the different pi bond? d pi, then d pi, p pi, then p pi, p pi. These are the three different pi bonds I can say. Among these, which is having highest strength? Which is having highest strength? Who is going to give me the answer? Which is having highest strength? Give me your answer, students. The highest strength here it is for d pi, then d pi, p pi, then p pi, p pi. This is the order of strength. Why? What is the reason? If I observe how pi bond is forming, pi bond is formed by the sidewise overlap. If you observe pp bond, they have to overlap like this. They have to overlap parallelly. When they overlap parallelly, what you can observe is see, this is how it is happening. When they overlap, they are overlapping like this. Because of that, the nucleus is actually having space here. Because of the space, there will be repulsion between the nucleus. Due to the repulsion between nucleus, the strength of these parallel pi bonds will be very weak. That is why p pi is very weak. Why d pi? In the case of d pi, that repulsion is not there. Because already the
the bond is more straightened.
Bond is? Are you asking any doubt or? Hello, Chris?
Sir.
Yes, what happened? What's your doubt?
Sir, in this case, d pi and first case, sir, bond is more straightened.
Bonding is more
strong.
Yeah, first here the bond is more stronger. Because you can see like already the lobes are already in that slanted position, and the repulsion is because of that this nucleus is having less repulsion. Okay, but here it was very closer like this, and when they overlaps, what is happening? it will move like this because of the repulsion. The repulsion will reduces the strength. So that is the order. Now if I ask you for same energy orbital, for same energy shell, or orbital, what will be the order? If I am asking you 2 p pi, 2 p pi and 3 p pi and 3 p pi, which is more stronger, 3 or 2? Tell me, which is more stronger? Who is going to?
2 pi.
Yes, very good. Here also same thing only. For same energy orbital, strength is inversely proportional to the internuclear distance, and this internuclear distance is a dominating one. The lesser the internuclear distance, that will be having the highest strength. Okay, if we compare different type of pi bond, even if you compare different type of pi bond, then also the one which is having lesser internuclear distance having highest strength. Okay, yeah, if it is clear, we can move to the next part. Shall we move? Can we move? Yes. Okay, next is a very important and high priority part of this chapter, that is the hybridization. Valence bond theory we have discussed. Now we will be discussing about the hybridization part. Okay, and for the hybridization, there are, what about the repulsion between the nucleus? So Rabbi, you are asking about repulsion between which nucleus? Repulsion between which nucleus? Between which orbitals or subshells? Let me know that. Yeah, are you talking about the 2p repulsion? Okay, I didn't get you properly. Okay, let me say 2p repulsion. Okay, repulsion is there. If I am both are p pi, this is also p pi, this is also p pi. Now if we compare different shell p pi orbital, both are p pi only, but this one is 2 p pi and this one is 3 p pi. Now if I compare this, what we have to go? We have to go with the one which is having lesser internuclear distance. 2 p pi is having lesser internuclear distance, so that will be having the highest strength. Okay, hope that was your doubt, or any other doubt? Okay, yes. Okay, Valence bond theory and hybridization. Hybridization is majorly about calculating the steric number. I am repeating, if you found out steric number, you can find out hybridization. If you got hybridization, you can find out geometry. If you got geometry, you can find out the bond angle. If you got bond angle, or if you got the steric number, you can find out the number of lone pair. All these things you can find out with one simple equation or formula, that is calculation of steric number. Take a note of it. Steric number is equal to half into valence electron of central atom plus monovalent atom plus number of monovalent atom. M is the number of monovalent atom and C is the cation. If we have a cationic charge, then you have to minus that charge, and if you have an anionic charge, then you have to add that charge. That is the simple formula to calculate steric number. Yeah, and if you got steric number, you can calculate number of lone pair. How you can calculate number of lone pair? Steric number minus number of surrounding atom. Take a screenshot or take a note of it. Is a very important one and the high priority part in this chapter. Yes. If it is done, put me a thumbs up. Yes. Are you done, students? Are you done? Okay. Everyone noted this one? Now we are going to solve the questions and everything about this. before that we will be discussing about how we can find out geometry, bond angle and everything. Okay, yes, I hope everyone have done with this, or do you want more time? Shall I? We don't have more time. Yes. Okay, now here is a table. If you got the steric number, if steric number is 2, then the hybridization is SP. Hybridization is SP and geometry is linear and bond angle is 180. This is fixed. This table is fixed. It is not going to change. If you found out steric number, remaining everything you can find out. And if steric number is 3, then it is SP2 hybridization, trigonal planar and 120 degree. How the trigonal planar will be looking? Yes, this is how the trigonal planar will be looking. And if it is 4, then SP3 and tetrahedral, and the bond angle is 109.5 degree. And how the tetrahedral will be looking? Tetrahedral will be looking, okay. This is how the tetrahedral will be looking. Tetrahedral means there will be 2 bonds in the same plane, and there will be another 2 bonds will be opposite to each other in the another plane. 2 will be below and 2 will be above, like this. 2 will be like this, another 2 one will be like this. Okay, now if it is 5, then it is SP3D and trigonal bipyramidal is the geometry, bond angle is 90 and 120 degree. And trigonal bipyramidal, yeah, this is trigonal planar, right? If I am putting one bond above the axis and one below the axis, that is trigonal bipyramidal. And octahedral, SP3D2 hybridization, steric number should be 6, bond angle is 90 degree. And 7, SP3D3 pentagonal bipyramidal and bond angle is 72 and 90 degree. So this is fixed. If you can remember this one, you can easily solve most of the things in the chapter. If you are done with this, let me know. I will be giving you few examples and I will be telling you how you can solve the questions using these formulas and all. Are you done? If you are done, give me a thumbs up. Okay, I think everyone got enough time to write it. Yes. Okay, now you got geometry and everything. One thing that is missing here is shape. How we can find out shape? How we can find out shape? Shape you can find out if you ignore the lone pair. If you ignore the lone pair, what you have to do is, geometry means there is a difference between geometry and shape. Geometry means it is the combination of both lone pair and bond pair. If you observe or if you look at both lone pair and bond pair, how the structure is looking, that is geometry. But if you close your eyes, towards lone pair, and how the structure is looking, that is your shape. That is a shape. That is only the difference. Geometry includes both bond pair and lone pair, and shape refers only the position of atoms. We will be ignore the visual of lone pair. Okay, that is what shape. I will tell you how you can. No need to remember the shape with respect to particular steric number and hybridization and number of lone pair. You can find out the lone pair. And if you found out the lone pair, ignoring that lone pair, you can find out the shape. I will give you examples of it. Here is a question for you. Predict the hybridization and shape of XeF4. You find out everything. For XeF4. First of all, find out the steric number. How we can find out steric number? Half into valence electron of surrounding central atom. What is the valence electron of central atom? Xe. Nobody guessed right. It is 8. Okay. Then number of monovalent surrounding atom. How many monovalent surrounding atoms are there? 4 fluorine is there, right? So X plus 4. Now is there any charge? There is no charge. So what I will be getting? 8 plus 4, 12, 12 by 2, it is 6. If it is 6, what is the hybridization? I got the steric number 6. If it is 6, what is the hybridization? Tell me, students.
Octahedral.
Yeah, very good. What is the hybridization I am asking? Geometry is octahedral, very good. What is the hybridization?
sp3d2.
Very good. sp3d2. sp3d2 geometry is octahedral. That is the geometry. Now if I am asking you what is the number of lone pair? What is the number of lone pair? How we can find out number of lone pair? Number of lone pair, steric number 6 minus number of surrounding atom. How many surrounding atoms are there? 4 surrounding atoms, which means you have 2 lone pairs. Yes, very good, Dhanashree. We got 2 lone pairs. Now we got lone pair and we got geometry. Now I will be arranging this lone pair and bond pair, and thereby I will be finding the shape. Okay, XC. How the octahedral structure will look like? There will be a square planar, and one above and one below will be having the bond. Now my question is, where I will be putting the lone pair? Here there is an equatorial plane, equatorial square planar, and there is an axial plane also. Where I will be putting the lone pair? Anybody have any idea? Where I can put? Axial. Yes, very good. Actually we can put anywhere because the bond angle is 90 degree. Bond angle is actually 90 degree. So, but as the bond angle is 90 degree, we can put anywhere. But what I will be doing is, I will be putting only in the axial. Not only me, everyone has to put in the axial. That is according to the UPSC convection. Okay, like if one put equatorial, another one put in the axial, we will be getting a wrong shape, right? So to make everything equal, according to the UPSC, we will be putting the lone pair in the axial position. So 2 lone pairs I have put in the axial position. Now you see how the structure is looking like. Close your eyes towards the lone pair, and how the structure is looking. What's the name of this structure? Yes, very good. It is square planar. That is what I am saying. You no need to remember the shape. What you have to do is just close your eyes towards the lone pair and see how the structure is looking like. That is what the shape. Okay, is it clear to everyone? Yes, everyone, I need the response. Yes, thank you for your response. Now I can move to a few more compounds, IF7 and ClF3. Students, find out for IF7 and ClF3. What is the steric number? What is the hybridization? What is the shape? For IF7, give me the answer. Tell me the steric number of IF7. What is the steric number you got for IF7? Okay, I will be solving it for you. Steric number half into iodine. Valence electron is 7 plus 7. 14 by 2, it is 7. If it is 7, it is sp3d3. sp3d3 means, what is the geometry? Pentagonal. Very good. Pentagonal bipyramidal. And what is the bond angle? What is the? Yeah, 72 and 90 degree. And what is the number of lone pair? 7 minus 7, it is equal to 0. There is no lone pair, which means if there is no lone pair, shape is equal to geometry only, which is nothing but pentagonal bipyramidal. If there is no lone pair, shape and geometry both are same. Okay, got it? Now my question for this one is, I will be drawing the geometry of it. Okay. Okay, this is added. Okay, my question is, if there was one lone pair, where you will be putting it, in the axial or equatorial? If there is a lone pair, where you will be putting the lone pair, axial or equatorial? Yes, we will be putting in the axial. Very good, Kiran. We will be putting in the axial. Why we are putting in the axial if there is a lone pair? Is it always we have to put in the axial? Is it always we have to put it in the axial? No. How we will be putting? We have to check the bond angle. Where, in which part there is a higher bond angle, there will be having lesser repulsion, and there we will be putting the lone pair. Okay. Lone pairs will be occupied in the maximum bond angle position. In the case of pentagonal bipyramidal, 72 is the bond angle of equatorial and 90 is the bond angle of axial. So I will be putting lone pair in the axial part. Okay. Yes, very good. It is all about angle. Now what about CLF3? Find out for CLF3. Find out all these things for CLF3. What is the steric number? That is the first thing I want. Can I erase this part? Are you all taken note of this one? Shall I erase it? Shall I erase or not? Just to give me some reactions. Yes. Okay. Okay, CLF3, what is the steric number? Steric number is equal to half into 7 plus 3, it is equal to 10 by 2, it is equal to 5. Yes, which means hybridization is sp3d and geometry is trigonal bipyramidal. And what is the bond angle? Bond angle is 90 and 120 degree. And what is the number of lone pair? Lone pair is equal to 5 minus this 3, that is 2. And what about the shape? Here I want to know what is going to be the shape of it. Okay, for that I will be drawing the geometry. Trigonal bipyramidal. Where I will be putting the fluorine? And where I can put the lone pair? Two lone pairs are there. Where I will be putting? Tell me, guys. Yes, triangular planar is the geometry. Where I will be putting the lone pair? Equatorial or axial? This is equatorial and this is axial. Where I will be putting? Axial. Are you sure we will be putting axial? I said you have to check the bond angle. Where there is maximum bond angle, here there is 120 degree. In the case of trigonal planar part, 120 is the bond angle. So where there is maximum bond angle, there only repulsion will be less. So where there is less repulsion, there we can put the lone pair. So I will be putting the lone pair in the equatorial position. Lone pairs will occupy in the equatorial position. Lone pairs will occupy in the equatorial position because equatorial bond angle is higher than the axial bond angle. Axial bond angle is what? Axial bond angle is 90 degree. If I put a lone pair in the axial position, there it will experience higher repulsion, which will make the compound unstable. Is it? Okay. Now what is the shape? Now if you close your eyes towards the lone pair part, how the shape is looking or how the structure is looking? Tell me how the structure is actually looking. How it is looking? Tell me.
In shape.
Yes, very good. That's only the shape. That is only shape. Ignore the lone pair and see how it is looking. So the shape, I can say it is shape is equal to T shape. Yes. Hope it is clear. Now I hope everyone can do all the questions from this part. Everyone? Sir, how to find steric number if the surrounding atoms are not monovalent? Okay, I can give an example. If the surrounding atoms are not monovalent, you should not add that one. You should not add that one. Okay, I will tell you. Yeah, are you done with this? Shall I move? Okay. Okay, example, if I am taking SO2, if I am taking SO2, how to find out steric number? Half into valence electron of sulfur, it is 6, plus how many? Plus how many? Plus 0 only. Oxygen is not a monovalent. Oxygen is not a monovalent. We have to only add the number of monovalent surrounding atom. If it is not a monovalent, then we have to put it as 0. What is the answer you are getting? You will be getting 3. 3 means sp2 is the hybridization. That's only. Got it? Yes. Yes, that's all about the hybridization part. Okay, now the next important part here is dipole moment. Dipole moment, you can see a lot of questions. Okay, shall we go with the dipole moment? Are you ready for it? 2 more topics are there, dipole moment and MOT. Yes, dipole moment. What is dipole moment? What is dipole? Positive, negative, 2 equal and opposite charge. 2 equal and opposite charge separated by a small distance. This system we will be calling it as dipole. This system we will be calling it as dipole. And for this dipole we will be defining a term called as dipole moment, which is nu. Okay, if the dipole moment nu is equal to 0, then we will be calling that compound as non-polar. If nu is not equal to 0, the compound is polar. The compound is polar. Dipole moment nu is equal to charge q into the distance of separation, that is r. And the presence of dipole moment is represented by the cross arrow put on Lewis structure on the molecule. Lewis structure on the molecule. Example, I am taking hydrogen fluoride. Hydrogen fluoride. The shift of or the direction of arrow will be from the one which is having electron, one which is having less electron to one which is having more electron. Okay. One example of charge. Yeah, sure, I can give one example of charge. Okay. Please give me go back. Okay. If I am taking another one, NO2 minus. If I am taking NO2 minus, what will be the answer? What will be the steric number? Half into valence electron of the central atom, that is 5, and minus. If it is minus, if there is a minus charge, what I will be doing? I will be adding plus 1 over here. If there is a minus charge, I will be adding plus 1 over here, and if there is a plus charge, I will be putting minus over here. So I will be getting 3. This is sp2. That is how you have to find out. Got it? Is it okay, Surabhi? Okay, yeah, welcome. Okay, presence of dipole moment represented by the cross arrow put on Lewis structure on the molecule. This question comes in the NEET exam. What is the direction of arrow representing? It is a shift of electron. Symbolizes the direction of shift of electron density. That is the main point. Direction of shift of electron density. Okay, this is about the short idea about dipole moment. I will be giving you a little more idea about it in the exam point of view. Shall I move this slide? Okay. 2 equal and opposite charge separated by a small distance, that is dipole. For that dipole we will define term called as dipole moment, and it is equal to charge into distance, and the arrow mark represents the direction of shift of electron density in the molecule. Okay. Okay. Now before going to this, I just want to add few more things. That is, if you got some molecule, how the direction of dipole moment will be getting the understanding of whether it is polar or non-polar. Example, I am taking a CO2 molecule. This is CO2 molecule, right? And you can see carbon is less electronegative, oxygen is more electronegative. So the direction of dipole moment is towards oxygen. Now here it will be towards oxygen. Now you can see the dipole moment in this particular direction is cancelled by the dipole moment in the left direction. So in this case we can say the dipole moment nu is equal to 0 and it is a non-polar molecule. Got it? Another example, if I am taking NH3. If I am taking NH3, where will be the direction of dipole moment? It is towards nitrogen. There is a lone pair also. Towards nitrogen. And the direction of dipole moment, if there is a lone pair is there, it is towards the lone pair. Now you can see dipole moments are all towards one particular direction. As it is on towards one particular direction, it is not going to cancel out. It is not going to cancel out. In this case, the molecule is polar. In this case, the molecule is polar. Okay. Now I can give you a few more examples. If you got a compound like this, okay, this is one compound, and is ortho and meta. Which is more dipole moment? Which is having more dipole moment in this one? Can anyone let me know? Then actually explain again. Which one you want to explain? About the CO2 or NH3? Which one? Okay, NH3, what is there in that? NH3, you know that the direction of dipole moment will be towards nitrogen because nitrogen is electronegative. So dipole moment will be direction is towards NH3. Okay, and if there is a lone pair, the direction of shift of arrow mark will be towards the lone pair. Now overall if you see, the arrow marks are not cancelling each other. See, arrow marks are not cancelling each other. It is moving in a one particular direction, which means some constructive dipole moment is happening here. Okay, but if there is an arrow mark in the upward direction and it is cancelling the lower one, and there is another one in the opposite direction, dipole moment in this direction, let's suppose it is plus x, this will be minus x, and overall dipole moment will be 0. Overall dipole moment will be 0 in this case. This case is not happening in the case of NH3. This is not happening in the case of NH3. That is why NH3 is having non-zero dipole moment and it is polar. Is that clear, Tanushree? Yes. Okay. Yes. Now my question is, now this is my question. First one and second one, which is more dipole moment? First one or second one? First one or second one? For this type of compound, how you can find out the dipole moment is CH3. CH3 is an electron donating group. CH3 is an electron donating group. For electron donating group, the arrow mark is towards the benzene ring. It is towards the benzene ring. You can also it is towards the benzene ring. Towards the benzene ring. Now how you can find out the order of dipole moment is, take these two dipole. Take these two dipole. Here you can see for this CH3 dipole moment is towards downward. Okay. Now what about for this CH3? I am exactly taking this dipole moment and I am fixing it over here. Fixing it over here. Now it is making an angle theta, right? It is making an angle theta. Now the same thing I am going to do for here also. Here also there is a dipole moment in the downward direction. And here you can see I am taking this dipole moment. I am exactly taking this dipole moment and I am fixing it in such a way that they are making an angle theta. They are making an angle theta. Now which is having highest dipole moment? Lesser the angle, higher the dipole moment. Lesser the angle, higher will be the dipole moment, because the angle itself is saying that both the dipole moment is in one particular direction, which is giving a highest dipole moment. Okay, and here some of the dipole moment in the lower direction will be cancelled out by the upward direction. It is more closer to the upward. So one will be having highest dipole moment than the second one. Is it clear, everyone? Is it clear? Yes, everyone? Okay, yes. Okay, now another point about dipole moment, that is there is a general rule for it. If there is zero lone pair, and if the surrounding atom is identical, zero lone pair, then the molecule is perfectly, if the molecule is perfectly symmetry, then the dipole moment will cancel each other. Then the dipole moment will be cancelling each other. Example BF3. If I am taking BF3 is having same surrounding atom. And it is having symmetry. If I am cutting along this axis, I will be getting two equal parts, right? Which means there is a symmetry. Okay, and there is no lone pair, there is zero lone pair. In this case, dipole moment nu will be equal to 0. How it will be 0 is dipole moment in these two directions. Will be cancelled out by the dipole moment in this direction. Okay, that's the point you have to note down. If there is same surrounding atom, zero lone pair and symmetry, then the dipole moment nu will be 0. Same thing if you can see for, if I am taking for CH4, it is tetrahedral. Same surrounding atom, zero lone pair, and symmetry is also there. If I am cutting around this axis, I will be getting two equal parts. Symmetry is there. In this case also dipole moment is 0. Got it? PCl5 if you observe, Cl, same surrounding atom. Please show the last slide. Which one? This one. Then actually you are asking for this slide or? Okay. Yeah, this side, one thing you have to note down is lesser the bond angle, higher will be the dipole moment. That is, you have to arrange the two dipoles in such a way that they are making an angle theta. And lesser the theta value, higher will be the dipole moment. Okay. Now for PCl5, if you observe, there is a trigonal planar. If I cut along that plane, I will be getting two equal. There is a symmetry. So here also dipole moment nu is equal to 0. Got it? So this is another point you can note down to find out the dipole moment easily. Shall I move? Are you clear with this, everyone? Students? How tetrahedral is symmetric? First of all, you should know how the structure of tetrahedral will be. Okay, let me take. Okay, suppose in tetrahedral two will be like this, two bonds will be like this, and the next two bonds will be, one will be like this and another one will be like this. Okay, if I get one more pen. Okay, another one will be like this only. Okay, you can see this is how the tetrahedral structure. Two will be in the below in same plane and two will be above in the different plane. Now if I am cutting along this axis, I will be getting two equal parts, right? If same surrounding atom is there, I will get two equal parts. Got it? That is why tetrahedral is symmetric. One will be like this, another one will be like this. If I cut along this, I will get two equal parts. Okay. Now one more point I want to add is, even though there is a presence of lone pair, example in the case of PCl2, even though there is a presence of lone pair also, there also they can make 0 dipole moment. In the case of PCl2 Cl 2 chlorine will be in the axial, and there is lone pairs on the equatorial position. Here also dipole moment nu is equal to 0. Even though there is presence of lone pair is there also, dipole moment is 0. Why? Because dipole moment in this direction is cancelled by the lower direction, and dipole moment due to the lone pairs are cancelling each other. Dipole moment due to these two lone pairs will be cancelled by dipole moment in dipole moment due to this lone pair. That is the equatorial plane. The equatorial plane. It is making a shape similar to BF3. Equatorial triangular plane are making a shape similar to BF3, in which dipole moment will cancels out. Okay, so in this case also nu will be 0. If lone pairs position are in such a way that they will cancel each other, then at that time also dipole moment nu is 0. Is it clear, everyone? Is it clear? Yes. Okay. Now tell me, XeF4 is polar or non-polar? This is a question for you. XeF4 is polar or non-polar? Tell me, students, we don't have enough time. How to find out whether it is polar or non-polar? Just draw the structure, or what is the condition we are having? Same surrounding atom, 0 lone pair and symmetry, then it is non-polar. Okay, first of all check the steric number. Steric number is half into 8 plus 4, that is equal to 6. Tetrahedra is the geometry. Tetrahedra is the geometry, and there is how many lone pairs? 6 minus 4, it is equal to 2. How many lone pairs? 2 lone pairs will be in the axial position. Now tell me whether is it polar or non-polar? Yes, very good, Surabhi, it is non-polar. Here you can see it is having symmetry, but there is lone pair. But the lone pair in this direction will be cancelled by lone pair in the opposite direction. And fluorine, both fluorines are cancelling out each other in the opposite direction. Okay, so the dipole moment nu is equal to 0 in this case. Got it? This is all about dipole moment. If it is clear, we can move into the last topic of this chapter. MOT, very important one. Okay, MOT, I will tell you, don't worry about MOT. There are tips and tricks to solve any questions from the MOT. First of all, MOT, we will be going into the relation between bond order, bond length, bond strength, diamagnetic and paramagnetic. This I already mentioned in the paper solving. What is the relation between bond order, bond length, then stability, then bond enthalpy. All these relations I have mentioned in the class. Okay. Now how we can find out bond order? That is the question. How we can find out bond order? Here is the equation to calculate bond order. That is half into number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. What is according to MOT is there are two atomic orbitals. The two atomic orbital will be combining together and will be forming two molecular orbital. One will be bonding molecular orbital, another one will be anti-bonding molecular orbital. Bonding molecular orbital is having less energy and is more stable. Anti-bonding molecular orbital is having high energy and is less stable. That is the idea of MOT. Okay. How to find out bond order is half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. And there is a trick or shortcut for the 14 electrons. For 14 electrons, bond order is 3. This is the maximum bond order we can see. For 14 electrons, the bond order will be 3. That is N2. Okay, now no need to see anything. I will be giving you the complete list of bond order from total valence electron 1 to 20. How we can find out that? Okay, before going into that, let's have a look on the electronic configuration. There are two electronic configuration. There will be two electronic configuration, that is for the molecule with less than or equal to 14 electron. For the molecule with less than or equal to 14 electron, due to sp mixing, it is following a particular electronic configuration. That is, first one is sigma 1s, then sigma star 1s, then the less energy is sigma 2s, sigma star 2s, and after that, after sigma star 2s, sigma 2pz is supposed to have lower energy. Sigma 2pz is supposed to have lower energy, but due to sp mixing, due to the mixing of s and p orbital, pi 2px will be pi 2px, pi 2py will be getting lesser energy comparing to sigma 2px. This is the difference. These two will be the difference between electronic configuration with less than 14 electrons and greater than 14 electrons. Okay, then pi 2px, pi 2py, and then the last one is sigma 2pz. Now if you look at the electronic configuration of greater than 14 electron, same, first with sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s. Now here you can see, here there is no sp mixing, here there is no sp mixing. Because of no sp mixing, the sigma 2pz will be getting the lower energy comparatively, then pi 2px and pi 2py. Then the remaining is same. These two only the difference. I can easily remember, you can easily remember it by just remembering 2 1. 2 1 for less than or equal to 14 electron, and 1 2 for greater than or equal to 14 electron. Okay, this question directly has come in the exam. What is the electronic configuration for less than or equal to 14 electron and greater than 14 electron? This question has come in the exam. That's why I am giving this electronic configuration. Are you done? I hope all of you know this electronic configuration, but don't make mistakes. Only difference is 2 1 1 2. Are you done? Shall I move? Take a note of the electronic configuration. Okay. Now the electronic configuration will be actually helping you whenever you are comparing the stability. I will tell you that one. Other than that, you no need to remember this electronic configuration. When the question is what is the bond order, what you have to do is just simply follow this table. It's going to help you to solve most of the question. That is, first thing you have to find out is the total number of electrons. If the total number of electrons is 1, then the bond order is 0.5. It is 2, then it is 1. 3, it is 0.5. 4, it is 0. Next, what you have to do? Copy this one and paste it. First copy, then paste. Then what is the next? Next, everything will be increases by 0.5 till 14 it will be increases by 0.5. Till 14 it will increases by 0.5. After 14 it will be decreases, bond order will decreases by 0.5. This is the easiest way you can find out the bond order. For 1 electron 0.5, 2 electron it is 1, then 0.5, then 0. Then copy it and paste it. Then from 9 onwards 0.5 increase till 14 electron. Then decrease by 0.5 till 20. Got it? Now I have a question. What does this mean? What does this mean if there is 0 bond order? Here you can see 0 bond orders are there. What does it mean? Can anyone let me the answer in the chat box? What does it mean by 0 bond order? Students, anybody have any answer? What does it mean by 0 bond order? 0 bond order means the molecule is not existing. If the bond order is equal to 0 means the molecule is not existing. If the molecule is not existing means the bond order is 0. Guys, you got the trick? Have you got the trick to find out the bond order easily? Or any doubt is there? Let me know. Can I move? Students, are you there? Are you there or you left? Okay. Take a screenshot of it. It's going to help you a lot in finding the answer in a short period of time. Okay. Now another question I will be asking here is paramagnetic and diamagnetic. How you can find out paramagnetic and diamagnetic? Magnetic nature. Magnetic nature. How we can find out? If the total number, write it in your notebook. If the total number of electrons is odd, then it is paramagnetic. If the total number of electrons is even, then it is diamagnetic, except 10 and 16. Except 10 and 16. 10 and 16 are paramagnetic. That is oxygen and boron. Note it down. How we can identify the magnetic nature easily. Note it down, everyone. Are you done with it? Yes. Please note it down. We can go for few questions and after that we can wind up the class. Please stay online. Okay. Are you done with noting down? Paramagnetic and diamagnetic. The chapter is over. Now we will do few questions. Yes. Okay. Here's a question. NEET 2025 question. Give me the answer, students. A hypothetical diatomic molecule with a bond order 0 is quite stable. Statement 1. Second statement is bond order increases, the bond length increases. Is it correct? What is the answer? Who is going to give me the answer? Is it correct or wrong? If bond order is 0, is it quite stable? Just now only we discussed. If bond order is 0 means what? The molecule is not at all existing. If molecule is not existing means 0 stability. So this is wrong. Bond order increases, bond length increases. Is it correct? Is it correct? Yes. Option D is correct. Both are wrong. Bond order increases, bond length will decrease only. Yes. Very good. Very good. Thank you for your answers. Okay. Next question. Okay. Here is a question for you. Hybridization. XeO3. XeO3. Very important question. What is the shape and hybridization? Use the steric number. I am not going to solve this. You have to give me the answer. For XeO3, just look at the steric number of XeO3. Half into. What is the steric number of XeO3? Who is going to give me the answer for the steric number of XeO3? Give me. Students, come on. XeO3, very good. It is 4. Xe is having 8 plus oxygen is not a monovalent, so it is 0. Then it is 4, which means sp3. sp3, and it is going to be pyramidal. Why it is pyramidal? Lone pair is there. Lone pair is equal to 4 minus 3. It is equal to 1. So it is pyramidal. Now what about XeF2? What about XeF2? What is the steric number? What is the steric number? Half into 8 plus 2. 5. Hybridization. sp3D. Yeah. What about the number of lone pair? Lone pair is 5 minus 2. It is equal to 3. What is the shape? XeF2. What is the shape of XeF2? Tell me, students, XeF2, what is the shape? What is the shape? Yeah, it is linear. If you observe how we can find out XeF2, it is trigonal bipyramidal, right? How many lone pairs are there? 3 lone pairs are there, and the 3 lone pairs will be occupying in the equatorial position. Then 2 bond pairs, fluorine, will be occupying in the axial position. Now how it is looking like? Straight. So it is linear. There's no doubt in that. Okay. So yeah, remaining you can do it by yourself. Easy only XeO4 and XeF6. What is the answer? Option C. A, 2, B, 1, C, 4 and yes. Very good. Option C is the correct one. Yes. sp3d3, it is distorted octahedral. If there is a lone pair present, in the octahedral geometry, it will be having a distorted octahedral shape. If there is a one lone pair, sorry, it's not octahedral shape, pentagonal bipyramidal. XeF6 is having pentagonal bipyramidal geometry, right? XeF6 half into 8 plus 6, it is 7. Pentagonal bipyramidal. And how many lone pair? Lone pair is equal to 7 minus 6, it is equal to 1. Fluorine, 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 fluorine. Okay, and here there will be one lone pair occupying. In this case, what will be the shape? Shape, we can say 2 shapes are there. One is distorted octahedral and another one is pentagonal pyramidal. 2 shapes we can say. One is distorted octahedral and another one is pentagonal pyramidal. Is it? You got it, students? Shall we move to the next question? Can we move to the next question? Yes, thank you. Yes. Another question, NEET 2025. I want everyone to solve this question. Dipole moment order, number of lone pairs, bond length and bond enthalpy. Yes. Give me the answers in the chat box. Dipole moment, you have to tell me. H2O, and NH3 if you observe, and CHCl3. Yeah. What is the order? Is the order is correct? Option C. A and D only. Okay, we can see that one. First of all, option A is correct or wrong? Option A is correct because here dipole moment is of hydrogen is higher. Sorry, dipole moment of H2O is higher. But why? Because oxygen is here. Here oxygen is here. Oxygen which is having highest electronegativity. Due to the highest electronegativity, the dipole moment value will be higher. And all the dipole moment will be having a same direction also. Now when we compare the NH3, nitrogen is not that much electronegative comparing to oxygen, so the dipole moment will be lesser. Then CHCl3, it is almost have a zero dipole moment. So the first order is correct. And this one, XeF4, what is the number of lone pair of XeF4? What is the number of lone pair? Steric number is? Yeah, tell me the number of lone pair. It is how many? 2. What about XeO3?
1.
XeO3 is coming 1, then XeF2? I think 3, right?
3.
Yeah, okay. So, is the order is correct? It's not the correct one. Now about the bond length. bond length. How we can find out for bond length? That's important one. Bond length we can find out if you check the bond order, CH and OH. Among these, which is having highest bond order? Check the total number of electron. NO is having 15 electron. If there is a 15 electrons, 2.5 is the bond order. Okay. Now if you for carbon and hydrogen will be having 7 electrons, right? Total 7 electron. Carbon is having 6, hydrogen is having 1. So the bond order is coming as what? 0.5 only, right? Is the bond order is coming 0.5? What about for oxygen and hydrogen? Oxygen is having 6, hydrogen is having 1. It is, okay, sorry, oxygen is having what? Oxygen is having 8, hydrogen is having 9 electron. This is also having, I think, 0.5 bond order. So among these, which is having highest bond order? NO is having highest bond order and less bond length. Okay. Now how we can compare for CH and OH? How we can compare for CH and OH? That is a question. Both are having same bond order. If both are having same bond order, one thing you can do is check the number of electrons in the anti-bonding pi star orbital. If more number of electrons are there in anti-bonding orbital, that will be less stable, or that will be having less bond order and highest bond length. Another one is check the size. Here you can see hydrogen is common, and carbon and oxygen, which is more in size? Carbon is more size, right? Oxygen is less size. As carbon is more in size, the length will be higher. More bond length. Okay, more bond length. So that is how you have to compare the bond length. Then bond enthalpy. Bond enthalpy you can find it out by using the bond order. N2 is having bond order 3, O2 16 electron. 16 electron bond order is 2. Hydrogen bond order. What is the bond order of hydrogen? H2. 2 electrons, right? It is 2 electrons, right? 2 electrons means bond order is 1. So bond enthalpy is directly proportional to the bond order. So N2 is greater than O2 greater H2. That is the order. So what is our correct answer? A and D. Very good. I think few of the students have given the correct answer. Very good. So students, this is all about the chemical bonding chapter. Many more questions are there. Everything I have added in the PPT, and solution also I have added it. All of you have to go through it. Because of the time limitation, we are not able to solve many questions, but I am very sure that with this concept you can easily able to solve any questions from this chapter. Go through the questions that I will be sharing in the group and prepare it accordingly. Okay. So are you okay with this? Shall I wind up the today's class, everyone? Yes. And tomorrow please be on time, don't be late. Because of that we lost 5 more minutes today in the morning. Yes, thank you all the students. You can leave.